E6H12O6 plus 6O2 yields 6 CO2 plus 6 water plus energy to do work. So the focus this time we're talking about these formulas is about the carbon and oxygen and not so much on the energy. Energy is still important, don't get me wrong. I mean, you can't ignore the energy, but it's more about the carbon and oxygen. And when you guys start thinking about your ecosphere, or if you've done your ecosphere, you know that there was a delicate balance between your carbon and oxygen in your respiration and photosynthesis within your ecosphere. At least there should have been. That would have been one of the things that you needed to be considerate of. You can't have too many animals doing too much respiration because you won't have enough sugars in order to keep up with them. Okay? You can't have too few animals because then you'll have a reservoir of carbon, you'll have the sugars, but you won't have enough carbon dioxide to keep photosynthesis going. So it's a delicate balance there in your ecosphere. Alright, that's carbon oxygen. Takes us to nitrogen. This drawing right up here is a little bit, I don't want you to go copying this whole thing down here. Okay, there's a lot to it. But here's the gist. The air you breathe, 78% of it is nitrogen. Remember, I told you need nitrogen for things like proteins, which make up 50% of the dry weight of your body, and nucleic acids, that's your DNA, that's your hereditary material. DNA, RNA, that basically directs what your body does, what it makes, all that kind of stuff. Okay? So you need nitrogen for those purposes. Nitrogen around you, 78% of the air, there's tons of nitrogen around you. When I breathe in the air, 78% of it is nitrogen that goes down into my lungs. When I breathe out, guess how much of it is nitrogen? All of it. Not all of it, but 78%. You cannot use nitrogen in the form of atmospheric nitrogen, which is around you right now. It doesn't hurt you. It's not harmful to you in any way. It's basically what we would consider to be inert. It doesn't do anything. You bring it in, you bring it out, you bring it in, you bring it out. You can't use it to make proteins. You can't use it to make DNA. Therefore, you need something to happen to that nitrogen before you can use it. And that's where the nitrogen cycle really comes in for us as humans and as animals, is the nitrogen cycle, atmospheric nitrogen, needs to be fixed, which we call nitrogen fixation. You'll notice that there's a terminology right here, nitrogen fixation. Guys, there's a lot of talking going back there. You guys need to, it's hard for me to talk to these guys over here. So nitrogen fixation, we're taking atmospheric nitrogen and we're converting it into usable form. And that's really what this right here is trying to tell you. This right here is atmospheric nitrogen right there. And what they're telling you is that they're showing it going into plants, okay? And they're showing it being transformed into a number of different nitrogen compounds. That's a lot of chemistry. And that's not what we're here for. We're not here for the chemistry. It's more for the understanding of where the nitrogen comes from, where it goes, and basically the fact that we can or can't use it in its different varying forms. Okay? So again, I have another video. This one also started out, when I first started out, it was like the first 30 seconds, I was like, oh my god, you gotta be kidding me, right? And then it gets better, I promise. Okay?
Hours turn to days.
Well, the commercial doesn't help.
You know why you're laughing so much? It's because of a gas, nitrous oxide. It is also called laughing gas. This is what made you laugh. Let me tell you, laughing gas is made of nitrogen and oxygen. Do you know that most of the air you breathe is nitrogen? Oh, you can breathe this nitrogen. It is not laughing gas. In fact, although the air around us is full of nitrogen, we can't use it directly. To get it into our bodies, nitrogen has to go through a nitrogen cycle. Understand? Okay, I'll tell you more about nitrogen. But let's go to the kitchen. I'm baking a cake there.
Promise, it gets better. Promise.
The cake isn't ready yet. We have to bake it first so that we can eat it. Nitrogen is just like this cake. Before we can use it, it needs to turn into other compounds. Did you know all living things need nitrogen to live? All of us, plants, animals, and humans, need nitrogen to make the proteins in our body. Plants also need it to make chlorophyll, the stuff that makes them green and helps them make food from sunlight. You really are hungry. So you gotta wait for the cake to bake. Just like nitrogen, which must be fixed for the plants to use. Lightning and some bacteria that live in some plants can fix the nitrogen in air for us to use. This is called nitrogen fixation. Not this plant. Special plants, called legume plants, have this bacteria in their roots. For example, soybean plants help fix the nitrogen.
Talk about this idea of fixing the nitrogen. Okay, taking atmospheric nitrogen, converting it into usable forms of nitrogen in the soil. This is done primarily by bacteria. It can also be done by lightning. Can fix bacteria and convert it into a usable form. Now they've mentioned legumes. Okay, in the case of legumes, I think legumes actually is French for vegetable, isn't it?
Yeah.
Something like that. You can see that's from my 1 week in French class when I was in college until I dropped out. Let's see, back over here. So let me add a slide here. That's not what I've been doing. Let me add a slide. Legumes are special types of plants that have a very unique relationship with those nitrogen-fixing bacteria. Do I have any vegetarians? Is there anybody a vegetarian? Whoa, that's a whole bunch. I had one in my last one. Okay, so I got a whole bunch. Okay? So, as vegetarians, you guys have to be very concerned about your protein intake, or you should be. Okay, that's definitely one of those things. It's like, if you eat a rounded diet, meaning that consists of meat and things like that, you get your protein usually from the chicken you eat, beef you eat, turkey, whatever it is you eat that way. However, if you are a vegetarian, your protein comes only from plants, specifically from plants. And therefore, you need to make sure you find plants that are high in protein. So, of my vegetarians, there are a bunch of you, what are the types of things that you guys usually eat in order to supplement or to make sure that you get enough protein? Okay, beans and lentils. Beans and lentils. Which are examples of legumes. Did you have another thing?
Soy.
Soy, okay, which kind of falls into this bean category, but we don't usually think of it as a bean, but yes, soy, okay, soybean. So, in that case, those are legumes. Those are examples of legumes. Now, a legume is a plant that, like anything else, you drive down Lake Road down here, and you'll drive by fields of soy. Okay, that's what is growing out there, I think, this year was soy. Okay, you drive down there, you'll see all of it there. They have a unique situation where the roots have these little nodules. Guys in the back, you need to be quiet again, please. That have these nodules at the roots, on the roots, which basically is a place for these nitrogen-fixing bacteria to hang out. So you have lots of these nitrogen-fixing bacteria. Instead of being dispersed all over the soil, they are concentrated in these nodules at the base of these things. If you were to go and you were to uproot a soybean plant, and you were to look at its roots, you would see these little nodules on the roots. And in there are tons of bacteria, and they're nitrogen-fixing bacteria. So what that does is it adds lots of nitrogen to the soil, which then allows these plants to bring up a lot of that nitrogen, making them high in nitrogen-rich compounds like protein. Now, an interesting thing related to, especially like you guys here locally, is what you'll see is, I just mentioned from the school, driving down Grover's Mill Road, there are two big fields on your right and your left. There's a housing development clustered in one spot on the right, and you keep driving down, there's a housing development clustered on the left, and then again, once you get past both those housing developments, there's farmland again on your right and your left. This year, those areas are growing soy. Do they always grow soy? No. What else do they grow? They grow soy and they grow corn. Usually it's corn and soy. And they rotate them. 1 year they'll grow corn, 1 year they'll grow soy. Or maybe 2 years they'll grow corn, 2 years they'll grow soy. It depends. And what it depends on is it depends on the soil. Corn is not a legume. Actually, corn uses up lots of nitrogen in the soil. It requires a lot of nitrogen to make corn. But it doesn't ever add anything to the soil. It actually depletes the soil of nitrogen. So what farmers have found is that instead of just having to pump the ground full of fertilizers over and over and over and over again, they found a natural way to resupply the soil with nitrogen. And that is to rotate their crops. It's called crop rotation. What they will do is they will plant corn, which for many, many years was a very what I'll call a cash crop. They make lots of things are made from corn, therefore it's very profitable to grow corn. Soybean for a long time was a throwaway crop, meaning that very few people used it. It wasn't used for a lot of different things. Okay, it wasn't as useful as it is today. Soybean no longer is a throwaway crop. It's used in a lot of different things, whether you know it's in there or not. Okay. Anyway, so what they would do is they would plant their fields with corn as often as possible. However, to naturally resupply the ground with nitrogen, they would plant a year or 2 years of soy in those particular areas. And they would rotate their crops. So this area this year will do soy, this year over here we'll do corn. Then next year we'll switch those. So that the ground keeps getting replenished with that nitrogen. Make sense? I want you over the next few years to pay attention to that out here. As you drive by the school, as you go from school to home, as you drive around town, look at all the different fields. And make note of that over the next couple of years. Hey, that last year that was corn and this year it's beans. Okay, I noticed that this year. Because you'll see a lot of that going on around town. Okay? So that's crop rotation specifically related to adding nitrogen. Do you guys know what the Dust Bowl is? You guys know that in history? Okay? Well, again, that's a perfect example of cycling of nutrients or the lack of cycling of nutrients. You've got people moving across the country, getting out into the Midwest, planting what they consider to be important cash-type crops or even just crops for them to have their own food, but they keep planting the same crops over and over on the same land, depleting the nutrients from the soil, making the soil very poor in terms of its overall quality. And therefore eventually resulting in very poor soil. It doesn't keep, it blows all over the place, all that kind of stuff. Again, I'm sure there's a lot more details to it in relationship to history and stuff like that, but that's the same concept. That's why that happens. And we had to find a way around that. Now, in this area we do crop rotation. Not all places do crop rotation. They supplement the soil with nitrogen using certain types of fertilizers. And that's a whole other conversation for a whole other day. Okay? So that within itself is a very interesting and, depending on who you talk to, a horrible thing at the same time. Okay? All right, so that's crop rotation related to soybean, legumes, things like that. Let's keep going with this video for the nitrogen cycle.
The bacteria in soil turns nitrogen into ammonia and nitrates, which plants can then use to grow. Now you know how plants get their nitrogen. Can you guess how animals get their nitrogen? Yes, by eating plants. Animals get their nitrogen from the plants. Are you wondering about the nitrogen going inside your body? It comes back to the soil through the waste animals produce. Yes, like this waste, animals also make waste. All that goes back to soil. When they die and their bodies decompose, the nitrogen again goes back to the soil for the plants to use.
When you guys are doing your ecosphere, this is going to be the primary concern that you're going to have is the nitrogen cycle. What do you do in terms of trying to balance out the carbon-oxygen cycle, meaning, producing carbon dioxide, bringing carbon dioxide in, producing oxygen, things like that, but balancing out that with the bacteria that need to break down the nitrogen from decomposing materials, whether it be the animals that die that fall to the bottom of your ecosphere that need to be decomposed, okay, in order to keep the nitrogen cycle going. You need to keep that going. And what is that delicate balance of not having too much nitrogen, but having enough nitrogen to keep it going? You guys are familiar with the fact that a lot of fertilizers are made of animal waste. Okay, it literally, if you've ever gone by an area that has just recently been fertilized or something like that has been added to a particular area, it smells like crap. It literally smells like crap because that's what it is. It's made from animal waste because animal waste is high in nitrogen. All right, certain types of nitrogen. Then when animals die, the same thing. You're returning their nutrients to the ground, and as long as it's a natural cycle, it's fine. The issue becomes when you overwhelm a particular closed ecosystem with any type of nutrient. Perfect example of that. A number of years ago, the Grover's Mill Pond, I don't know if any of you guys live over near Grover's Mill Pond, but I'm sure that many of you have driven past it for for many years now. A few years ago, the Grover's Mill Pond, when you would drive by it in the summer, smelled terrible. I mean, it basically smelled like rotting vegetation. It smelled like crap, is what it smelled like all the time. And the reason for that is because of too much nitrogen. What would happen is you have nitrogen in things like animal waste, you have nitrogen in people who fertilize their lawns, in agricultural runoff, and it all filters down into the water, which in this case is Grover's Mill Pond, which is a relatively secluded piece of water, okay? It all filters down in there. Now you have an increase in nitrogen being one of the primary components in fertilizers and in animal waste. So a buildup of nitrogen. What would happen is in the water then, the plants in there, the algae and other things like that, would then undergo what we call an algal bloom. They take in the nitrogen and they would reproduce very rapidly. Photosynthesis, plenty of sunlight, especially in the summertime, plenty of sunlight, lots of nitrogen, they reproduce very rapidly. Then what happens is, when they reproduce very rapidly, okay, some of them, they're going to, basically you see, it's almost like green, just looks like a giant green layer of crap on top of the water. Okay, and then that stuff starts to die, and it builds up on the bottom of the lake as it dies. Then what happens, the bacteria gets at it, starts breaking it down. As the bacteria starts breaking it down, it's using up lots of oxygen in the water, so that kills the fish, because there's not enough oxygen in the water, it's low in oxygen in the water. It releases energy, heat, which also isn't really good for the water, and you've got this buildup of decaying material on the bottom of the water. So it becomes shallower and shallower, increasing the problem even further. So literally you have a giant rotting lake is what you end up having after a period of time, and it smells terrible. And that's what happened. I don't know how many years back now. Now, do you know what they ended up doing in order to try to fix that problem? Anybody know what they did over there? What did they do over there? They did this. Again, I'm losing track of time. 5 years ago, they did this. Nobody knows what they did? You haven't noticed a difference over there in the last few years? Last time? I mean, it hasn't been too bad. It's getting pretty bad over here in Plainsboro. Grover's Mill Pond has been pretty good the last few years, I've noticed. It's not perfect. I mean, don't get me wrong. There's parts of it that are kind of still gross, but they put in like those, you'll notice little things sticking out of the water that are like fish hatchery type areas and stuff like that. They dredged it. You know what it means to dredge it? They go in there, they literally scoop out all the crap on the bottom, and they haul it away, and they go dump it somewhere else. Okay? But basically what they're doing is they're digging out the bottom to make it deeper. Therefore giving more room, more water, more place for oxygen, more storage for oxygen. Hopefully you don't have that same, thing piling up. Now, over time it's going to happen again. We still have nitrogen runoff. We still have waste product. We still have people fertilizing their lawns and things like that. Nitrogen's going to run back in there. You're going to have algal blooms again and stuff like that. But hopefully we've taken some steps and precautions to help minimize that as much as possible. But it's only a matter of time until if they want to keep it the way that it is, they're going to have to dredge it again eventually. Okay? Carnegie Lake, for example, actually has been dredged a number of times over what separates Princeton from West Windsor, basically. Carnegie Lake has been dredged a number of times. Anyway, so let's keep going here. Sorry about that. But that's the reason. It's because of throwing off the cycle, throwing off too much of one nutrient. You think you ever hear you can never have too much of a good thing. It's not true. Okay, it needs to be in balance, especially in ecosystems. And that's where your concern will come in when you're doing your ecosphere, is making sure you have that delicate balance. You need to consider energy, obviously, energy input and flow, but you need to also be much more concerned with a closed container that you're going to be able to keep that cycle going naturally without causing an imbalance in any of those nutrients. That's going to be the major concern.
So tell me, what is nitrogen? Great. Do we need nitrogen? Superb. And how do we get that nitrogen? Wonderful. You have understood how we take in the atmospheric nitrogen. You now know how nitrogen in air is fixed so that all living things can use it. Do you want to know how this nitrogen goes back to the air? Some other bacteria do this work. They change ammonia and nitrate back to nitrogen, so the nitrogen cycle can be completed. This is just like the nitrogen cycle. Round and round and round, in the air, in the soil, in the plants, in the animals, in the soils, and back to the air.
Look, he blinked again. Oh my god. That's so freaky. So scary.
All right.
No, but like, it's like his eyes are so.
So this is just a visual. Again, basically what we just talked about. Obviously you can see that bacteria are going to be the most important part of this nitrogen cycle. Bacteria are critical. Other decomposers such as mushrooms and things like that are obviously important as well, but by far, both for the fixing of nitrogen as well as the returning of nitrogen to the air, and then that change in between. Like I said, I'm not concerned with you guys knowing that, atmospheric nitrogen comes in, becomes ammonia, ammonia goes through nitrification to become nitrites, and nitrites go through nitrifying bacteria to become nitrates, the assimilation in the plant. I'm not concerned about all of those steps, what they're called, what those molecules look like. That is not my concern. My concern is understanding why nitrogen is important, why we have to fix it, so to speak, okay, and eventually how do we get it into our bodies and incorporate it into our proteins and nucleic acids. That's the key. All right, and then the last slide I have for you guys today is this one, and literally this is all I'm going to say about it. Phosphorus cycle. There it is. Okay? Now, as far as phosphorus is concerned, phosphorus cycle is highly geological. So from a biological standpoint, phosphorus is critical for DNA, RNA, things like that. It is important. But most of the cycle is geological in nature. So we're not going to focus most of our attention on this. You need to know that phosphorus is cycling, but I'll tell you right now that if you really don't address it in your ecospheres at all, I'm not too concerned. My focus on your ecosphere, think about that. Cycling of nitrogen, and how the nitrogen cycle is a primary component, and honestly the limiting factor probably in most ecospheres. 2, carbon-oxygen cycle, and 3, the energy flow through it, including things like trophic levels and losing energy and how you maintain numbers, energy pyramids, and energy pyramids, biomass pyramids. Biomass is also going to be a critical component. So there's a lot of things that come through. I mean, the first time I ever saw an ecosphere, I think I was in like Brookstone or something like that, and I walked by one. And I just couldn't wrap my head around it as a biology teacher. I couldn't wrap my head around it. And then when I found that website for the ecospheres, the same sort of thing, like reading through it and seeing what the components were, and then also seeing that you needed to recharge it, was like, oh, okay. So that is something that you guys should all be looking into and trying to again, understand and grasp those concepts in order to show your proficiency towards those particular learning objectives. Okay? Anybody have any questions for me today? No? You're done. Good job. Okay? Thank you.